Hello everyone, today we are going to be talking about power management system, otherwise known as a smart fan project. Because here we're going to be using a fan and we're going to be converting it into a smart fan that actually recognizes presence and absence of motion. And that was then try to control the amount of energy which is being utilized by the fan. In this particular project, we're going to program this fan to sense motion and also allows users to use the remote control to also control it at their own time. The goal of this particular fan is to ensure that during working hours that when nobody is on seat, the fan can notice this and then turn itself off. And if the user comes back and decides to regulate a particular fan speed, he or she could just pick up on the remote controller and select a speed of its own using the remote active mode. Okay, so next thing we're going to be doing, we're going to be talking about the circuit diagram. Okay, looking at the circuit diagram, we could see that the circuit diagram has our artmax 32 PURC IC and RTCDS 3231. We have our PIR sensor, we have our 3-channel relay module, and from here we could also see that we have an FTDI ISP programmer, and we also have our crystal oscillator 16 megahertz connected to pin 9 and pin 10 of the ATmeg. We have our 16 by 4 LCD, and we have a 10k potentiometer that is connected to the VO or the wiper of it. Okay, here we're highlighting the header pins. Okay, so going over to, we have the header pins of our FTDI ISP programmer. Next is our 16 megahertz crystal, which is connected to pin 9 and pin 10 with 22 picofarad that is connected to pin 9 and also connected to pin 10 with the other terminals all grounded. Next we have our push button, which is connected to the reset pin, which is the pin 1 of the ATmega 28PU with a pull-up resistor supplying 5 volts to it. Next we have our voltage regulator. For those of us that are using more than 5 volts, maybe say 12 volts, so you might want to, like, bulk down to 5 volts. Next we have our 16 by 4 LCD, which we use in this particular project, and where we have where the reset pin is being connected and the enable pin and the 4 data pins, since we are using 4 bits. And after that we have our LED indicator that is connected to pin 13 in series with a 10k resistor. Okay, sorry, 1k resistor for 10k or 1k, any of them will actually, depending on the one you want. After that we connect our RTC and our PIR sensor as shown in this particular circuit diagram. It's also good to know that the ROTC, actually you are going to be needing 2 of its pins to connect to analog pin 4 and analog pin 5. Okay, next we have a relay module, which is a 3-channel relay module with the input pins showing the connections in the analog pin. We're going to be using analog pin 0, 1 and 2, or analog pin 1, 2 and 3. Okay, so next is the fan coil and also the fan regulator, and after that we have our AC input, which is 220 or 240 volts since we are in Nigeria. Okay, so that is about the explanation of the circuit diagram so far. Next we are going to be moving on to soldering this particular hardware component together to form our standalone S. So looking here now, we need a solder, we need some LEDs, we need our 22 picofarad capacitor, we need snappable wires, and we also need a steel board. So if we place our socket on our steel board, we solder underneath it, then we connect our 5 volts and our GND to the power rails, and after that we connect our 22 picofarad, we connect our 16 megahertz crystal, and then we'll solder our header pins for our FTDI ISP programmer. After everything, we should have something that looks like this, something that shows where our LCD is going to be connected, our 10K potentiometer, our push button, and our 100 nanofarad capacitor, our voltage regulator for regulating the output voltage. So for us to test this particular standalone board and see if it's working, we could run a Boolean sketch to it and see if the pin 13 LED that is connected there is actually working. Or we can also connect our LCD display to it, and we burn a display sketch. By connecting our LCD and we run the program, we could see that the LCD is on and we could see a display. So zooming in, we can see here that display is working, but which means that the standalone board is actually working very well. And after this, we'll move over to the fan. We actually need to remove the speed regulator from the fan, but before that, let's go and look at our sketch, our program. So from here, we imported the wire.h library, which is we needed for the IR receiver. After that, we imported the ROTC library and the EEPROM, which we are going to be using to save the data, which the ROTC is actually bringing. And after that, we imported the IR remote library, and after that one we imported the LCD library, and here we define the register select, which is pin 3, and the enable pin, and the other 4 data pins that we use. You can use any type of your own. And after this, the rest of this particular sketch is focused on making sure that this program works on 2 modes. First, is going to be able to allow user to set time, working time, at which they are going to be around the office, such that when they are around the office, it can actually sense motion and then turn itself on. And when they are not in the office and it is no longer sensing their presence, it's going to turn itself off. And then the other mode, which is the remote control mode, the users could be able to use this particular remote control to select a speed of their own choice. Another way to define these two modes of this power management system is also that you could set a working hour such that when you are around, you can select a speed of your own choice, either from speed 1 to speed 3, or when you are not around it, and it's on auto mode, it can then select a constant speed of its own, and in one sense that you're not around, it's just going to turn itself on. Here we show where we connect our speed, which is from A0 to A2. Also where we connected our receiver pin for the IR and the PIR, which is pin 10. The rest are just variable names which you assign for sensing. And other program codes here involves functions that we created just to make sure that we achieve the goal, and the goal, which is the working operation of this particular smart fan. All of them are all highlighted here. I wouldn't really bore you with all the whole techniques, so let's just run through it one more time and move over to the original construction. But before we go and hack our normal standing fan and redesign it, it's also good to know that some of these particular functions here, like the speed function, like the speed 0 1, the speed 1 functions, what they're actually doing is to set a particular pin high using the analog right, set it high or low, such that if we want to run on speed 1, for example, other analog pins will go down to 255, while the pin which is controlling the speed 1, or the speed 1 input of the relay, will automatically be 0. Since we are using a 3-channel relay module that is actually active low, so which means that you only need to feed it 0 voltage. So from here now we can see that we've hacked our standing fan that we usually use at home. We've removed the speed selector, and from there we're actually bringing out 3 wires, okay, 4 actually. One of them is going to be the live and from there we can then connect the remaining wires. So looking at it from there, we've already brought out the whole wires, all the whole four wires actually all coming out. One of them is going to be the neutral wire, and it's also very advisable that you label your wire so you will not actually cause yourself some confusion during the process. Okay, so so we say here that the neutral AC wire is not among this particular wire. So next thing on this list now is to do your wiring. You connect your 5 volt power supply. It's better you use switch mode power supplies, because even when there's low voltage, you can still alternate, or like give a feedback to the transformer so that it can output more current and then offer stability for you. Then next, connect your PR sensors and your LCD according to the circuit diagram. Then after that, you solder your AC switch, solder a female block, so that you can always just plug your AC plug straight to it. Then next, that use your glue gun and glue the AC plug straight. And after that, you connect your relay module. You connect the common of the relay module to the AC life. Then you connect the respective speeds to the AC fan coil. So you see from here now that we're connecting our AC life to the common, and then we're bringing our output for the speed regulation. And it's also very important that the neutral of this AC is being connected to the neutral of the fan direct. So we connect the AC live to the common of the relay module, and then we'll bring out the three outputs that we're going to connect to the fan coil directly. Okay, so after that, the next thing we're going to do, we're going to glue this relay module to the base of the plastic casing. And after that, once that is done, we'll connect the wires to the fan coil, just like we extended them. And after that, we'll screw them back into condition. Oh, before that, it's good to know that we have to bring out our IR receiver module outside, so it can be receiving IR signal from the transmitter, which is on the remote controller. Then once we are done with that, and I think we are good to go. So for testing the design, what we have here is okay. So when you are testing, you could just set the fan into the remote active mode by using the time, pressing the channel. It gives you the mode, and you set the on time and set the off time. And once you are in the remote active mode, you could press any of the 1, 2, 3 button. This, when you press 1, it's going to give you the speed 1. When you press 2, it's going to give you the speed 2. When you press 3, it's going to give you the speed 3. And then you press 0, it's going to turn the fan off by itself. So this is actually in the remote active mode, and this particular remote active mode is being governed by time. So from here, we'll have that in a remote active mode, we've already pressed selected 2 and is on speed 2 already. Now the next thing that we're going to be doing is we're going to test for the motion sensing mode. Now for the motion sensing mode, you could just leave it on for some time, and after that you will see that the fan will automatically turn itself off. Now if it senses motion, once the time is under the motion, is within the motion sensing mode, it senses motion, automatically it will kick in. Okay, so that's that about that, and I hope you like the video. Please comment, like, and please subscribe. Click the notification button for next